We're gonna give this a whirl again. I had a bit of trouble with the first video. Let's see. This is my first time with the new board, man. It's writing silly, but here we go. So listen. Today we're gonna do scatter plots, and it will say to write the equation of the line. We're not gonna do that today. All our interest is creating the scatter plot and then saying what kind of correlation you notice between them. So if you look at this first example here, all these dots are kind of going up and to the right. They're not in a perfectly straight line, but they're all kind of going in a similar direction. So that would show a positive correlation. These ones, the second one, they're all sloping down and to the right. So that shows a negative correlation. And these ones, they're all over the place. So there's really no strong correlation between those points. So let's try out. Alright, let's see here. Our first example, we're going to make a scatter plot for the set of data. Identify the correlation, sketch a line of best fit, and find its equation. Again, we're not going to find the equation today. If you're interested in finding the equation right now, you can talk to me in class, and I'll be happy to work with you on one, but that's not where we need to be. We're just going general scatter plots right now. So if you were to count how many little boxes there are on this thing, there's 19 going in every direction. You just want to make sure that you scale your stuff proper. So I see the first thing they give us in the chart is minutes played. So that's going to be our x-axis, minutes played. And I noticed that the highest one is 39. Now, if I have 19 spots, 19 times 2 is 38. It won't quite fit the 39, but the 39 would just be a little bit to the right. So we're actually just going to go by 2s, and then our 39 will hang off the edge. There's also 19 going up and down, and our points scored is going to be our y-axis. So I see the highest point scored is 31. So we'll just go by 2s in every direction, and that would include everything. So let me see if this will work with me here. Alright, so this is our point sort. And then down here will be our minutes. And our minutes are going to go by the same scale. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8. Alright, so I'm going to plot these points in red. So at 28 minutes, they scored 16 points. So here would be 28, 2, 4, 6, 8, 10, 12, 14, 16. So you're just going to plot the points like you would a normal coordinate. At 35 minutes, they scored 13. So here's 32, 34, 35-ish, and that was 13. 2, 4, 6, 8, 10, 12, 13. We have 8, 2, which would be here. Let's see, 20, 12, 2, 4, 6, 8, 10, 12. We got 39, 31, so that'll hang off a little bit over the edge, and up to 31, be about there-ish. We have 23, 10, 22, 23, 2, 4, 6, 8, 10. 19, 9, 19, 2, 4, 6, 8, 9, right there-ish. 27, 15, 2, 4, 6, 8, 10, 12, 14, 15. those dots, always think from left to right. They're kind of all going up and to the right. So that would show a positive correlation, which makes sense because you would think the more time you're in the game, the more points you're going to score. Unless you're me and you're just chucking up air balls the whole time. But more likely, you are making more baskets the more time you're in. So that would show a positive correlation. If we are doing the equation for the line, there's one way you can do it is with a calculator. You put in all the points, it tells you the line of best fit. Great. I already told you guys I wasn't going to tell you how to do this, but just in case, a way you could do it is you could draw yourself a line, try to hit as many points as you can or get them as close to as many points as you can. So like let's say we use this. And then you can figure out the slope between two of those points. And you can figure out the slope by subtracting your y's and subtracting your x. Change in y over change in x. That would give you the slope. Then you take a coordinate, you put the slope and the coordinate in the point slope form, transform that into slope intercept form, and you're done. And it's so much fun, so exciting, but that's not where we need to be. We just need to be able to plot them right now and to show what kind of correlation you notice. So we got one more. Anthropologists can use the femur or thigh bone to estimate the height of a human being. The table shows the results of randomly selected sample. Make a scatter plot for the data with femur length as the independent variable, which means the x. So here would be our femur. Come on, there we go. And the other one would be the height. Sure why it's not letting me write like that. Oh, is that right? Okay, there we go. Now, by the way, wouldn't you think the longer someone's leg bone is, the taller they're going to be? Right? It'd be pretty strange if you had a real short femur and you were 9 feet tall. So I would assume that there's going to be kind of a positive correlation, maybe, rather than a negative one. Let's see what we got. So if we are scaling these correctly, the femur length, the highest they go I see is 46. So if we said we had 19 spots, I know 15 times 3 would be 45, so 16 times 3 would be 48. So we could go by 3's each time, and we'll have a little extra. So like 3, 6, 9, 12, 15, 18, 21, 24, 27. And you might use a different scale than your friend, but if you're correctly scaling it, the graphs will end up looking the same. They'll have the same correlation. So 1, 2, 3, there's 36, and then it'll be 45. All right, and then the height, highest one I see is 187. So if there's 19 spots, 19 times 10 is 190, so that would include it. So we can go by 10s. 2, 20, 30, 40, 50, 60, 70, 80, 90, 100. 2, 3, 4, 150. All right, let's plot these points. 36, 160. 36, 160 is right there. We have 32, 143. 32 would be about here. And that was 143. About there-ish. We got 46, 187. 46, 187, that's going to be our highest point. 29, 142. 35, 161. 38, 164. 3140. And 27, 131. So again, you could have a break in the graph if you wanted and kind of skip and start at 100, because all of them are greater than 100. But again, we don't need to worry about that right now. If you look, they're